Okay, so now we're on section 6.2, and this is really just more of what we did in section 6.1, but the problems are a little bit more complicated. So you have several questions in your homework just really throughout this whole chapter where they give you a picture and expect you to use that picture for more than one part of a question. So first of all, please make sure you're not writing in your book. Second of all, what I found to be helpful is to draw a picture for each part of the question, or on something like example 1 here where it's a really complicated picture, maybe draw the picture in pen and then label it in pencil for, say, part A, and then you can erase it and label it again for part B. So that's what I'm going to do for this here. If you see it online, the notes that I have filled out, you'll see that A and B are done separately, just because I wanted you to be able to see the picture with the example and not have it erased. So you could always print that off if you like that better, or I can make a copy of it if you need me to. Just let me know. Okay, so in this case, they've given me that E is 1,500, so we'll put that in here. D is 900. ECD, so follow the letters, ECD is 20. And EFD is 30. Now, I highly recommend before you start the question that you just double check that you've got everything in the right spot there. And I'm actually trying to find K. Well, the problem is I don't have enough information in this triangle to find K. To find K, I could use Pythagorean theorem if I knew these two sides. I could use trig if I knew another side and an angle, and I don't. So let's look over here. Do I have enough information here to give me a side maybe? No. Okay, how about down here? Well, down here I know two sides, so I could find that third side. So that's where I'm going to start. I'm going to actually start off by finding F. So it might be helpful maybe to draw a picture of what's going on here. See, we should have room. We can squeeze it in right here. So here is, I'm sorry, wrong triangle. Okay, so this is the triangle that we're doing right now. So I know 900, I know 1,500, and I'm looking for F. So that'll help me when I set this up here to make sure I set it up correctly. So 900 squared plus F squared is equal to 1,500 squared. So F squared is going to equal 1,500 squared minus 900 squared. That's actually going to be 1,440,000. And luckily for me, when I take the square root of that, that gives me exactly 1,200. Now, if it doesn't, kind of depends on what you're doing here. Being that F is not really what I want to find, I'm trying to go all the way to K, you'd want to keep it exact. So if you can't take the square root of the 1 million, blah, 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 leave it as a square root. So that way it's exact. And then just carry that on through your question. Okay. Now, if it would be helpful to you, go ahead and now put in here what F is. So F, I know now, and actually I'm going to do this in red since I just found it. That's going to be 1,200. Okay. So now, again, I'm trying to come up with some side here in this triangle. Now that I know a side right here, I could use trig with this angle to find either H or I. H is not really helpful to me, so let's find I right here. So in that triangle, let me draw that one over here. So I know 1,200, I know 20, and I'm trying to get I. So that's my opposite side, that's my adjacent side. I can use tangent. So tangent of 20 is equal to I over 1,200. So 1,200 tangent of 20 is equal to I. Now, because I'm doing a tangent of 20, this is not going to be a pretty answer. That's going to be approximately 436.76, and it keeps on going from there. But again, I'm trying to get to K, so I don't want to round that off. I actually want to keep that answer and use that answer for the next part. So there's a couple different ways we can do that, and I'll show you here in a second. I can use the answer key just to use that number again, or I can actually even store it, and I'll show you in a second how you can do both of those. Okay. So now, I know what I is. It's just a yucky number. I'm going to keep the fact here that it's circled that I know that one. Now let's find K. So for K, this is the triangle again that we've got going on here. 30, K, and I. So I know I, I'm trying to find K, and of course I know 30. So that's my opposite and my hypotenuse. So the sine of 30 is equal to I over K. Well, I know I, it's just a yucky number. So the sine of 30 is answer, that's that number that's still in my calculator, over K. Okay, so to solve this now, we're going to multiply both sides by K. So K sine of 30 is equal to answer. And I'm looking for K, so K is equal to answer divided by the sine of 30. Now I'm going to go ahead and write down what that answer is, and then I'll show you how you do that in the calculator. So K is approximately 873.52. So if we do 3 sig figs, that's going to be K is 874. Okay. So let me show you what that's going to look like here in the calculator. Okay, so our computation we did earlier was 12, oh, hold on, let me check my mode here. I'm not in degree mode. Once you change that, it should stay unless you reset the calculator or maybe change the batteries or borrow one from somebody else. So when I found I took 1200 times the tangent of 20. You don't have to put a times in between. The calculator knows that it's multiplication. I hit enter, and then there's that number. So again, I've got two options. I went ahead and figured out what I was going to have to do with that number. I'm going to be dividing it by the sine of 30. So I can just go ahead and hit divide. If that doesn't automatically pop up though where you need it, hit second and the negative button, and that'll pop up the word answer. Divided by sine of 30. And that gives me the 873.52, which again is 874 to 3 significant figures. Now, another option that we can do with this 1200 tangent of 20, okay, hit enter. So what if you need to do a couple other things and then you want to come back to that number? So one thing that you can do is you can store. So over here, sorry, right here I can hit this store button, and when I do that, notice the word answer pops up, so it's going to store the number that I just did. I hit store, and then whatever you want to call it. So we're going to, if you want to, we can call it the letter I. That'll make it easy to remember. So let's see, I is here, A, B, C, all the way to I. So I'm going to hit alpha to choose the I and hit enter. And now anytime I use the letter I, that's going to be 436.76, so on and so forth. So in my question, instead of using the word answer, if I left the word I there, and let me show you kind of how this would look. My suggestion would be, if you're going to do that, maybe to kind of put a circle around the letter I so you know that you actually know that. But at the end here, I would have K equals I divided by the sine of 30 instead of the word answer. So in your calculator, when you're ready to use the I, you hit alpha, and then I, divided by the sine of 30. And you can see that answer up here at the top. Notice we get the exact same thing. So it's a helpful thing to do. That I will stay that number until you call I something else. You can always use the same letter if you want to. I think it's helpful to use letters that correspond to your question, so that's totally up to you. Okay. All right. So now let's look at example B. Now, okay, slight problem here. Hold on just a second. All right, so I just put in another picture here so you can see it next to the actual problem. So CDA is 39. D is 192, H is 300, K is 265, and I want to find the size of DEF. So I'm looking for this angle right here. So this one's going to start off much like the last one in the fact that I'm going to have to start way over here to get to where I want. Again, I don't have enough information in the right triangle. I would need another triangle on the right, I should say. I would need another side to be able to find that angle. Coming over here, all I have is one side, so that's not going to be enough to help me. So I got to start over here. In this case, I'm going to have to use trig because I don't have enough to do the Pythagorean theorem. So the side here that I know is my opposite side. And let's find f again first, because then that's going to help me with the triangle up above. So in this case, that's going to give me, well, we can draw a triangle in here if you want to. 39, 92, and f. So that's opposite and adjacent, so that's tangent. Tangent of 39 is equal to 192 over f. So f tangent of 39 is equal to 192. F is 192 over the tangent of 39. Okay. So that one, turn my page here, is approximately 237.10. But again, I don't really want to use that number. I want to keep that number as F. So we can use answer or we can store that as F, whatever you want to do. But now that I know F up here, and I'm going to redraw that triangle, F, I'm just going to put a circle around it. I know what F is. And I know that this is 300, and I would really like to know I. So I really have no choice here. Even though F is a yucky number, I have to use it. I know nothing else, and I need to get to that I. So I can do the Pythagorean theorem. So F squared plus I squared is equal to 300 squared. Again, I know F. I'm going to circle it there because I know what that is. So you can either store that as F or you can use the answer key, whatever you want to use. So I squared is going to be 300 squared minus F squared or minus answer squared. I end up with I is 183.80, so on and so forth. So again, this came from the 300 squared minus F squared, that's I squared. Take the square root of that to give me this. So be careful, that's a common mistake that students forget to take the square root. The number should seem way too big. Remember, F is not the hypotenuse. It should not, and I is not the hypotenuse. They should not be bigger than 300. So that would be an indication you maybe forgot to take the square root. Okay. Well, now that I know I, I'm looking for this angle up here, and 265. I can use trig. I can use an inverse to find that theta. I know what I is, so that's going to be my adjacent and my hypotenuse. So the cosine of theta is equal to I, which I know, divided by 265. So your I is going to be answer. Answer is always the number that you just got as an answer. So if by some chance I wanted to use the 237.10, that's not answer anymore. Answer is going to be this number that I got right here. So again, either store it as I, use the answer key. I'm going to do the inverse cosine of I over 265 or answer over 265, and I get that my angle is 46.1 degrees. Now that's the answer that they're going to be looking for in the back of the book. They're going to be looking to see that you've carried these decimals all the way through. If you round, you might get carry-through points as far as your final answer, but you're going to lose points because it's not as exact as it could be. Okay, so now we've got some story problems. So angles of elevation and depression, these are made by a horizontal line and a diagonal line of sight. Now it's very important here, horizontal line, not a vertical line. So this very first one here is the one that people mess up a lot. Angle 1 in this picture right here would be the angle of depression from the airplane to the building. This angle always goes down. A lot of times students want to put the angle over here. That would be like with a vertical line, and it's never with a vertical line. It's always a horizontal line. This dot right here that's not called anything. Sometimes you might know that angle, but it's not an angle of depression. Angle of elevation, that's going to be the angle that goes up in this case from that line of sight up to the airplane. Both of those angles, again, touch a line of sight. That diagonal line is your line of sight. And the angles are always congruent because they are alternate interior angles. So you've got your parallel line, you've got your transversal, those two angles are always congruent. So the reason I point that out is if you don't like the angle of depression, if you're not sure, is it here or is it over here, then just use angle of elevation instead, because those angles are always going to be the same. Okay. So first example here, you do definitely need to be able to draw your own picture. That's going to be part of what I'm going to be looking for. We have a 20-foot ladder that leans against a wall so that the base of the ladder is 8 feet from the base of the building. What angle does the ladder make with the ground? Okay, so here is your building, or here is your wall. Here is the ladder that's leaning up against the building. It's a 20-foot ladder. And that ladder, the base of the ladder, which means the bottom of the ladder, is 8 feet from the base, or the bottom of the building. And what angle does the ladder make with the ground? Okay, so there's the ground, so the angle is going to be down there. Reread the question, look at your picture, make sure that everything is in the right spot, and then now solve it. And do make sure that you label what it is you're looking for so that I know what you're solving for. I'm looking for the angle right here. Okay, and if you don't like theta, you can call it x. I don't really care. Since I'm looking for an angle, I'm going to use an inverse trig function. So my opposite side would be there, so I don't have an opposite. I have adjacent and hypotenuse. So the cosine of theta is going to be 8 over 20. And we're going to do the inverse cosine of 8 over 20. That's not reduced, but it doesn't matter. Type that in your calculator. That's going to give me your theta. Theta is approximately 66.4 degrees. Okay, that's it. I don't need to see this middle step. I'm just reminding you how you get that answer. But definitely I need to see the picture, I need to see the setup, and then of course the answer there. Okay. All right. The next one I gave you a picture just because it's an airplane, and I am not an artist, and I especially don't want to draw an airplane. If you have a question though that involves an airplane and you're not an artist either, you can always just write the letter A for airplane. Draw a box and label an A inside it, just so you know that that's where that is. This airplane is flying 3,500 feet above ground when it starts its descent to land at an airport. So the airport would be like right there. How many miles from the airport is the airplane when it starts its descent? Okay, so you could also put that 3,500 over here as well. Okay, that's how high the airplane is right now. It's starting to go down. The angle of descent here is the same thing as depression. So notice that 2 degrees is going straight across down. Now think about how small 2 degrees is. If you were descending 2 degrees and you put that angle over here, that airplane's going almost straight down, and that should make absolutely no sense. Okay. How many miles from the airport is the airplane when it starts its descent? Okay, so think about how the airplane's going to travel. The airplane's going to go diagonal, so that's the number that I'm looking for there. Sometimes they actually are looking for, this distance right here. And normally when that's the case, they will say ground distance, or they might even say horizontal distance. Okay, so here's my right triangle. That 3,500 here, we can switch over here as well so that I can see that triangle. But again, if you don't like that 2 degrees there, you can put the 2 degrees right here because that is congruent. Whatever triangle you're more comfortable looking at there. Either way, I've got my opposite, I've got my hypotenuse, that's going to be sine. So the sine of 2 degrees is 3,500 over x. So x sine of 2 degrees is equal to 3,500. We divide here. And I get approximately 3849.12, so on and so forth. Now, this is in feet. Look at what they asked me to do. How many miles? Okay, well, I'm going to have to do a conversion. Now, why didn't I do that conversion right off the bat? Well, if you remember, 1 mile is equal to 5,280 feet. So if I were to convert this 3,500 into miles, I would divide it to figure out how many miles that is, and that's going to be a horrible decimal. So wait till the end. You're going to get a more exact answer that way. So I'm going to take this amount of feet and I'm going to divide it by how many feet are in a mile. So I'm going to divide this by 5,280. Again, keep that number in your calculator. So that number's still there. Hit divided by, and it'll say answer, 5280, and I end up with 0.729 miles. Okay. All right, a couple more here. Now this is going to be a section that you use the solutions. The solutions in your book are pretty good. If you can't figure out what they did, make sure you ask me. Anytime that we have leftover before or at at the beginning of class, at the end of class, before school, after school, any other time that you have a free time, let me know, because this section is going to be, well, actually all of them are going to have parts, that might be a little bit more complicated. Okay, so a surveyor stands 200 feet from a building to measure its height. The angle of elevation to the top of the building is 35 degrees. How tall is the building if his instrument is 5 feet off the ground? Okay, so here's my building. Now this triangle right here that we're dealing with is 5 feet off the ground. So when I find this missing side right here, x, that x right here has another 5. So once I figure out what x is, I'm simply going to add 5 to it. So, tangent of 35 is equal to x over 200. Now, one thing to point out, a lot of these story problems use tangent because most of the time you know the adjacent side to your angle and you're looking for that opposite side. Think about how easy it would be to measure this distance, but how hard it would be to do this. And you have instruments that can measure that 35 degrees. So, a lot of times you'll have tangents. So, don't let that bother you if it seems like you're using tangent a lot. 200 tangent of 35 is equal to x. So x is approximately 94.8. But again, that's 5 feet off the ground. I need the entire building there, so we're going to add 5 to that. So 99.8 feet would be my answer. Okay, last one. Zach is standing in front of an office building. He's standing 300 feet from the building. So let's go ahead and draw that first part here. Okay, so here is my office building. 300 feet away is Zach. And the angle of elevation to the top of the building is 30 degrees. Now notice they didn't say anything about how tall Zach was, about any kind of instrument being so far off the ground. So in this case, you're assuming that either Zach is laying on the ground or that the instrument that he's using is on the ground, because I have no other way of doing it. Okay. Now, Zach notices a flagpole on top of the building. The angle of elevation to the top of the flagpole is 32. Okay, so basically now what's going on is I've got two triangles here. Okay, so we've got another triangle going on here. Here's my building with a flagpole on top now, same building, but now the angle of elevation, we're still 300 feet away for Zach, but now the angle is 32 degrees. We want to figure out how tall is the flagpole. Now hold on, my picture is not accurate because this angle is going to the top of the flagpole. Okay, so I don't know if you can tell with these pictures drawn separately like this. Sometimes when they're drawn together, it's a little bit hard to see. In this triangle here, if I solve this for what you would think you would solve for, I'd be looking for this value right here, the height of the building. If I solve over here on the other one, I'm going to be finding x, which goes all the way there. I just want to know how tall the flagpole is. But if I solve for x here, and actually let's call this one y over here instead of x. And if I solve for y over here, I can subtract those two distances and I'll be left with the flagpole height. Okay, so over here now, that's opposite and adjacent again. That's tangent. Told you that's going to be used quite often. So 300 tangent of 30 is x. X is approximately 173. Now, in this case, this might be a good one for you to store. Store this one, store the next one, and you can actually subtract 2 letters in your calculator, the same way we did the bringing up the store before. And I can show you here in a minute how we can do that. But I'll tell you what, well, I'll show you that here in a second. Okay, over here for this one, that would be tangent of 32 is equal to y over 300. So 300 tangent of 32 is equal to y. Y is approximately 187 feet. So y minus x is going to be the flagpole. So 187 minus 173, that's going to give me 14 feet. Now let's actually try this in the calculator just to see what kind of difference it makes if I store these numbers instead of rounding them off and then subtracting. So I'm going to call this one actually B for building and F for flagpole. Okay. All right, just because I don't want to store something as X, we use X a lot when we graph and so on. Same thing with Y, so I'd rather not store things as that. Okay, so to find my height of the building, I took 300 tangent of 30. Okay, and it was about 173. So let's store this as building. So that's going to be alpha B. Okay, and then for my flagpole, I took 300 tangent of 32. And I'm going to store that as F for flagpole. Okay, so now I'm going to take my flagpole, F, and I'm going to subtract my building, B. Now, of course, since I found the flagpole, that was last. I didn't really need to store that because I could have just subtracted B from my answer there, but that's okay. We subtract there, we get 14.25 and so on. Now, that actually would be better now because when I do 3 significant figures for my answer would actually be 14.3. Now, I don't have enough experience with your book yet to know if that's the answer that they would want. But I feel like on the exam, if they see that you rounded both answers to 3 sig figs and then subtracted, that for this question that would be okay. But 14.3 would actually be the best answer. Okay. So that is section 6.2. So the next section, we will move into triangles that are not right triangles. And then from there on, we'll kind of be doing assortment. When you have a right triangle, you can use Pythagorean theorem. You can use sine, cosine, tangent. If it's not a right triangle, we'll have a couple more resources we can use. Again, make note of any problems that you have questions about. Make sure you check out the solutions. Those are in Google Classroom. And let me know if you've got any questions.